I am Dr. Praveen Chaurasia, working as an assistant professor, Department of Electronics and Communication Engineering in the IMS Engineering College, Ghaziabad, which is affiliated to Dr. APJ Abdul Kalam Technical University, Lucknow. In this lecture, we will talk about image enhancement in spatial domain, at where histogram based technique we will also talk about. In previous lecture, what we have completed related to image enhancement of this particular subject, that is digital image processing. So, if we talk about the image enhancement technique, then we have different kind of techniques, that is point processing, spatial domain, and one another thing is also there. So, if we talk about the point processing, then in previous lecture we have covered histogram modeling. Okay. So, histogram modeling in previous lecture we have completed. After that, the another, that is the contrast enhancement, we have also contrast enhancement, that technique we have also covered in previous lecture. Now, the another kind of image enhancement technique we will talk about in this lecture. So, that is just based on the spatial domain, at where we can operate the image enhancement using different kind of coordinate. Okay. So, let us talk about this thing, and you can also observe then related to previous technique, that is called point processing, we have covered linear function in previous lecture, at where you can observe the relation between g and f is actually providing the relation of a straight line. So, that kind of relation is just showing the linear kind of function. In this lecture, we will talk about the non-linear functions. Which kind of non-linear function is? If one function is not a linear, then we can say we have to have follow the another kind of relation between them, that is called the non-linear kind of relation. Or we can say, for example, if y is equal to m s is the linear one, it is the example of linear function, then you can observe the non-linear kind of function is nothing but, if you say on a y axis, or you can say vertical, if we have a y, then on the horizontal axis if we have a x, then y equal to e raised to power x is just giving the linear kind of function. So, that is just a basic definition of linear kind of non-linear kind of functions. Okay. And your diagram is also giving in this kind of information here, where y is this one and x is look like in this manner. So, that is just a non-linear kind of function. So, this phenomena is actually you may observe related to the point processing technique of image enhancement, and that is actually the spatial domain. What it is? What is the meaning of spatial domain here? You are operating the coordinate, right. So, using these coordinate you can get the value of another one. If we have a f image, then you just converted your image in a different kind of image, that is the enhancement, and it is nothing but it is a g kind of g type of image. Okay. So, that type of function we can use to get the enhanced version. Now, you can observe here the non-linear gray scale transformation. So, here if we talk about, this is the original image value, original image, right, and let us consider we have f I comma j type of digital image. So, here I am considering f kind of image is just a original one, and g kind of image is just a enhanced version of this image. Okay. So, that is enhanced image, and for each kind of pixel you can function, you can call the function like g of I comma j. Okay. Now, what is the relation between f and g according to non-linear type of function? So, here it might be exponential type, it might be x square type, it might be square root of type, it might be natural log type. So, y can be exponential of x, y can be x square, or we can say if we talk about enhanced version, then we are just taking the g. So, y is also you can observe that is g, and x is you are using f word, that is f of I of j. Okay. So, you can also observe in this manner. So, if we have the f image in this axis, then you can directly get the value of g related to these kind of nonlinear functions. So, these all type of function are belongs to the nonlinear function. Okay. So, that is just a we can say no, that is just a nonlinear type of variable, or we can say functions. Now, if we talk about these kind of x square, or we can say x raised to power q. Now, here I am just generalizing x raised to power gamma. Okay. So, gamma is just a syntax value of this exponent value of x, and if gamma is greater than 1, then your curve is look like in this manner. If it is less than 1, or you can say if gamma x raised to power 1 by 2, then you can see the previous diagram, that is the square root. So, square root is just having this kind of diagram. If you are saying the x square, then you can say gamma is greater than 1. So, your diagram is your function is look like in this manner. Okay. So, gamma is just a exponent of this function. So, here using the gamma correction, you can also get the enhanced version of image. Now, this is the syntax which is used in a Matlab to identify the enhanced image. So, here you may observe if we have a enhanced image, that is g, and g is related with the original image function, that is capital F, then we have to have identify f minimum and f maximum using the histogram, as we can also observe this thing in previous lecture. And after that, then enhanced image is also giving the idea of g minimum and g maximum and the gamma exponent, that is very important. So, using the value of gamma, you can identify the enhanced image. If gamma is high, then your function is look like in this manner, or we can say what is the significance of this function and what is the significance of this function, you may observe here. Then choose one point, this thing, if f is in this particular location, let me consider that is L minus 1 by 2, okay, and your g point is lower to the, this point should be the, I think g divide L minus g is equal to L minus 1 by 2. So, at f equal to L minus 1 by 2, then using the function of x square, or we can say if we are choosing gamma is equal to 2, then your image pixel of that particular value L minus 1 by 2 is just a lesser than of this value. Okay. So, if f is raises, then your gamma is not raises in that particular manner. If f is totally L minus 1, that it will become a L minus 1, otherwise it will decay, it will increases in this particular way. If you see the root of x value, or we can say gamma is equal to 1 by 2, then you can observe that that particular value holding the value of g equal to L minus 1. So, according to this relation, you may observe the changes in a image, in one particular image. Now, you can see here, if we have the t equal to x square and your histogram is look like in this manner, then you can say that is a completely gray level 0 to 255, and here the number of pixels you may observe, here. Okay. So, here you can say the 100 value of gray level are holding how many pixels holding the 100 value, then you may say that around 1200 pixels are holding the value of 100, that is the meaning of histogram. So, if we choose that kind of nonlinear equation, then you your image will become in this manner. Enhanced version is look like in this particular manner. If we choose another nonlinear kind of function, that is t equal to square root of x, here gamma is nothing but it is 1 by 2 and here gamma is equal to 2. So, here you may observe if gamma is decreases, then your important thing is actually giving the good result, and outer portion is not that much giving very good enhanced image. Okay. So, here you may observe that value is just a showing black one, or you can say that is having a higher value of pixel. So, here you may also observe the histogram. So many value are having that label, okay, 200 label instead of this. So, that is actually shifted towards this one. Okay. So, that is actually giving the idea of gamma 2 to 1 by 2. So, if gamma correction is used, then that type of phenomena you may observe. Now, if we see another kind of example, then if we choose a nonlinear type of function, that is t equal to e raised to power x, then your histogram is look like in this manner, and you may observe then most of the pixels are holding the value of 0 to 100 only. Very few pixels are holding another kind of value, these kind of pixels. Okay. So, your pixels is actually belongs to f of I of j is less than holding the most of the pixel are holding 100 value of this pixel. Now, if we choose another kind of nonlinear function, that is t equal to log of x, then you may observe then most of the part is will become white. Okay. So, you can observe if 0 is a black portion and 256 is a white portion. So, you may observe up to 1600 pixels, are holding more than 200 value. Okay. So, here we are choosing the white portion of 255, that is showing the white portion of gray label, and 0 is belongs to the black label. So, your picture will look like in this particular manner by using the nonlinear type of functions. Okay. So, you may I think very much understand what is the gamma correction is actually doing to get the enhanced image by using nonlinear kind of grayscale transformation. Okay. Now, if we talk about the function of image averaging, that is also the one kind of point processing term. So, if we talk about the image averaging, so here we have to find the average of pixels as well as their noise is involved in that particular pixel. So, see if we have a enhanced image, that is g of I of j, then if we talk about m is equal to n, then 1 upon n is actually your pixel is summarized with the noise function, that is n k of I of j, and your summation you are taking care from 1 to n, then it will look like in this particular manner. So, that is the complete your original image, and the noise value you may add it up through this. So, your image is actually averaging there, and your averaging it just look like in this particular image. In this particular example, you may understand the what is happening inside the averaging of one particular image. So, see that is the one image which is the original one, and that is also same image, but it is just little bit hazy as compared to the previous one. Okay. So, both image is actually summing up. Okay. That image which is having more noise and that image is having lesser noise, that actually all kind of image is actually summing up each other, and after that you may get the totally enhanced image. Averaging, how we can nullify the noise? Then we can say most of the portion is actually not providing the actual value. So, we can say if these pixels are giving some noise value and that pixel is not having that noise value, then they are actually removing that kind of thing. So, that image is actually get enhanced here. Okay. So, that portion is actually you are removing that portion, because that portion is actually not repeating itself. So, we can say because that portion is actually repeating in the here also, here also. So, you can just take that picture only, and at the last here there is nothing. So, you cannot repeat that thing. So, at where the most of the repeating portion are there, then you can get the enhanced image. So, it is only for gray level, gray scale range image enhancement possible using image averaging. That is the limitation of that kind of averaging. Gray scale range of that particular enhancement is possible only. Okay. So, that is just a limitation present in this particular image averaging. Now, if we talk about n value, if we have a n is equal to 1, n equal to 2, n equal to 8, n equal to 16, then you may observe the clarity of the image. So, microcells image which is taken from the Addison Bell's lab, and you may observe if n is increases, then your image is get enhanced by 1 by 1. Okay. So, if we have a n equal to 1, then your image is noisy one. Here you may observe the additive Gaussian noise, that type of noise we will also talk about later. And if we take in account n equal to 2, or we can say 2 image of these kind of image we are taking into the account, because if you are increasing n, this is the value of n. Here if we taking this only, then n is equal to 1. If we are taking this image and this image, then n equal to 2, and you are getting the combination of these two here only. Okay. So, after n equal to 2, what is the output? This is the output. Okay. So, this kind of image are not having any value of increasing n, because n is equal to 1. If we have a n equal to 2, or you are making the average, you are taking the average from 2 original image, then your image is look like in this manner. If you are taking 8 kind of similar image, then your image is get enhanced in this particular manner. Okay. And if we take the 16 kind of same image and you are taking the average of there, then your output will become in this particular manner, right. So, microcell will become enhanced if your n is increased. Okay. Now, if we talk about the Matlab code of cumulative histogram, because histogram modeling is also the point processing kind of modeling. So, if we talk about the Matlab code, which is actually taken from the third reference here, if we talk about the third reference, then it is the third reference, which is nothing but it is the textbook, and it is the advanced version of textbook, that is the digital image processing using Matlab. So, that third book we have taken the Matlab code here. So, that is the Matlab code by which you can observe the histogram, image histogram you may observe, and the cumulative histogram is also having such kind of syntax, that is HISTC, histogram cumulative. Okay. If we talk about the histogram array, then you have to take the 0 to 255. So, log int is the function of we are calling here, and hist is just again we are assigning this that is the single one. And if we talk about the cumulative histogram hist c of I, then your histogram must be divided by m into n, where m and n are the dimensions, and your I is actually varying from 0 to L minus 1. How many level are there? So, 250 level 256 level are there total, then we can say that is a 0 to 255 is the value of I. Now, if we talk about the histogram and cumulative histogram of image, then you may see if we have the original image is this one, then histogram of this particular image you may observe in this manner. Then what is the histogram actually saying? 0 to 256 label are present at the x axis and number of pixels are showing in the y axis. So, you may observe the 1000 pixels
are holding the value of what between 150 to 200 level, okay, 150 to 200 value of that particular 1000 pixels are holding actually. Okay. So, that information is actually provided by histogram, and after using the histogram cumulative function, then you may get these kind of histogram. So, it is you may observe that your histogram is actually cumulated one. Why it is so? Because we are using this kind of function. Okay. Actually, you are taking the summing up divided by m into n. So, you are actually taking the average of this. Okay. So, that is why it is distributed in this particular manner. Okay. So, that is the diagram of cumulative histogram. So, that is just a giving the idea of this one, and after the cumulative histogram your image is get enhanced in this particular manner. Okay. So, original image is different one, and after the cumulative histogram your image is get enhanced in this manner. And now, if we talk about the histogram equalization, which is actually used for contrast enhancement and image normalization. Okay. So, here the probability theory you have to use. Okay. Now, if we have the g function here and with the probability function of p of f this and input image is f, then your diagram is giving this kind of situation, and your function of p of f is nothing but it is histogram of f divided by m into n, and p g of g will become a straight line. Why it is so? Because we are taking care of this rectangle one. So, that function is related to 1 upon L minus 1. Now, if we talk about the value of p of f and p of g of u, then you may observe that that value is coming like g upon L minus 1. Okay. So, that is why it is nothing but it is a rectangular one, it is a curvature nature, and it will become a rectangular nature. Why it is so? Because if you solving this thing, then your integration you have to taken into the account, then with respect to u, then if you apply the limit, then it will become a g of g upon L minus 1. If it is discrete one, then you may observe in this thing. So, for the continuous thing you may observe in this manner, and if we have a discrete thing, then same function is also you look like, and after you are reaching in this particular thing. Okay. Now, if we talk about input image, that is the input image here we are taking, and after the image histogram equalization your image is look like this manner. So, that image is just the output of histogram equalized process. Okay. So, after doing the histogram equalization your image get enhanced in this particular manner. So, for the input image your histogram is look like in this way, and after the image histogram equalization process your image is will become this particular manner. How we can equalize the histogram? Then you may observe the most of the pixels 7000 pixels are holding the value from at that particular point to that particular point, are holding the value from 110 to 160. Okay. So, 110 to 160 150 range are having 7000 kind of pixels. Okay. And if you equalize the each and every pixel, then your histogram is look like in this manner. How we can equalize this histogram? Here you may observe by neighborhood pixel. What is the value of neighborhood pixels? Okay. That thing you have to observe, and after the value of image histogram equalization, then your image is get enhanced. Now, here you may observe that pixel is looking like a higher value. If we talk about the 0 value is belongs to the black one, and 255 are holding the white one, then the neighborhood pixel you may observe here that is look like a white portion. So, after the image equalization, then it will generate the enhanced image, that is the white portion of this particular histogram. Okay. So, your images get enhanced by using this particular process, that is called histogram equalization. Okay. So, each and every every picture is justifying this thing. Okay. So, how we can done the histogram equalization, then you may observe this particular method. Now, these are the references we have opting here, okay, in this lecture. So, we have covered so far for this particular lecture, and another thing we will talk about in next lecture. Thank you.